culture and history, it has a colorful festivity. One people in harmony, one people in great revelry. Tanggap City is proudly celebrating milestones and beyond. A never-ending celebration, a joy for everyone. Come and join us, let's all have fun. It's a legacy that we have done. A bright future of our city is at hand. Tanggap City, simply home. 25 years of cultural fame, endless beauty in silver years. Magical symbols every Christmas, people dancing on festivals. Golden years of prosperity, we are proud of this great city. One people, one destiny. Tanggap City is a place to be. Tanggap City is proudly celebrating milestones and beyond. A never-ending celebration, a joy for everyone. Come and join us, let's all have fun. It's the legacy that we have done. A bright future of our city is at hand. Gearing for progress and development, people remain focused to their commitment. Preserving the tradition of good values into Tanggap City, simply call our home. Tanggap City is proudly celebrating milestones and beyond.
Good afternoon, constellations of stars, especially to our senior high school learners who are with us in our FB Live.
Welcome to Astral Academy Cyber School. We are live in Dipid Tayo Tanggub and Astral Academy FB page.
I am Sherry May S. Epong from Tangub City National High School.
And I am Siti Badria Manalocan de Tudakula, also from Tanggub City National High School.
And we are your teacher facilitators today. Good afternoon, Ma'am Bads.
Assalamualaikum. Good afternoon, Ma'am Sherry.
So today is December 7, 2021. We will be discussing week 5 in the subject Discipline and Ideas in the Social Sciences.
Yes, Ma'am Sherry. So again, welcome learners for our week 5 and the second quarter of this semester. So for this week competency, analyze and apply the basic concepts and principles of the major social sciences, ideas, theories in examining sociocultural, economic, and political condition, hermeneutical phenomenology. Okay, so humans as a complex being cannot be studied by mere sciences or arts alone. Social sciences develop different studies and methods to explain and interpret various phenomena experienced by humans.
Yes, exactly, Ma'am Bads. No? So, social science ideas, no, as a senior high school student, no, and future advocate of change, it is advantageous, no, on your part that you possess relevant knowledge to understand social phenomena and, of course, discern among alternatives. So, for this week, now we will analyze and apply hermeneutic phenomenology in examining socio-cultural, economic, and political conditions.
Okay, Ma'am Sherry. So I would like to remind our senior high school learners that for this week, you need to answer the activity sheets in your SLMs, and that is why you need to listen and listen attentively for this discussion. Yes, Ma'am Sherry. So before we go further,
Let's have a break.
let us have a short break.
Yes. So more discussions when we return. This is Astral Academy Cyber School. And we are back, still in Astral Academy Cyber School. We are still live in DepEd Tayo Tanggub and Astral Academy FB page and YouTube channel. Okay, ma'am, no? So since our learners know our target competency, so let's proceed to deepen our learners' understanding, ma'am, about our competency this week, no? About hermeneutic phenomenology. So, and to start with that, ma'am, let's first define, no, these two terms, hermeneutic and phenomenology.
Okay, Ma'am Sherry. So for the definition of hermeneutics, it is the study of literary text. Scholars frequently adhere to a set of rules or a specific system on which base their interpretation. The specific rules used to interpret and understand a text are known collectively as hermeneutics. So, for the phenomenology, it refers to a person's perception of the meaning of an event as opposed to the event and exist externally to outside of that person. Inquiry on how human mind can grasp the true nature of things as experience in the world.
Yes.
So hermeneutics means
Interpretation.
interpretation. So when you say phenomenology, it is the perception
Yes,
of
ma'am.
human being
In a natural
in
setting.
a natural setting.
Yes, ma'am.
Okay.
So yes, no. Hermeneutical phenomenology, ma'am. So it is actually a qualitative research methods, no, a methodology that arose out and remains closely tied to phenomenological philosophy. So it is actually a strand, no, a strand of continent philosophy. So philosophy and method of interpreting human experiences. No? So as a means to understand the question of what it is to be human. So interpreting human experiences. No? So if we are to look into the beginning or the etymology of the word hermeneutics, ma'am, it is from an ancient Greek mythology, no, the god Hermes served to interpret messages from the other gods. So like Hermes, name, the term hermeneutics come from the word for interpreter.
Okay.
Okay, so that is the etymology of the word hermeneutics from the Greek god Hermes. Okay?
Okay. So okay, so in what do you call this? Hermeneutics phenomenology. So we should have this we called
Yes, ma'am.
proponents. So we have Edmond Husserl, the father of phenomenology, to gain understanding of the underlying structures found in everyday experiences and of how consciousness can grasp this concept.
Yes, ma'am.
Okay, so Martin Heidegger, disciple of Husserl, he is credited for having started hermeneutic phenomenology. Humans are thrown into the world who already possess established rules, norms, standards, and histories in the society.
Okay, so aside from Heidegger, ma'am, no, we also have Hans Georg Gadamer. So he extended Heidegger's work into practical application, no, sa hermeneutic phenomenology. So historical tradition enables people to understand one another and interpret text. That's according to Hans Georg Gadamer.
Okay.
So aside from that, there are two communicating persons daw, no? Have their own understanding and interpretation of the world and have their own prejudices. So textual interpretation is also made possible as the interpreter finds common ground with the text in terms of language. That's the proposition of Gadamer, ma'am.
Okay, so let's proceed to criticism and limitations. So lacks the application of scientific method. Intentional, since scientific method is even criticized as contrary to perception that holds no preconceived judgments. Phenomenology is not a method, but ways by which consciousness derives meaning.
Yes.
Okay, so phenomenology, it is not a method. So as we defined earlier, that phenomenology is the perception
Yes.
of
A
a
person.
person perception to the natural setting.
Yes, and based on his or
Based
her
on her
experiences.
experiences.
Yes, ma'am.
Okay.
So that is why this study also is being criticized, no? And nakita po nato ang limitation, ma'am, na hermeneutic phenomenology lacks the application of scientific method. So we will continue, more discussions after a short break. This is Astral Academy Cyber School. And we are back, still in Astral Academy Cyber School. Okay, okay, Ma'am Bads, no? So, let's have a recap, Ma'am,
Yes,
with
Ma'am Sherry.
our lesson this week, no,
Okay.
in the ISS.
Okay, so we have discussed the hermeneutics or hermeneutical phenomenology. It is a qualitative research methodology that arose out of and remain closely tied to phenomenological philosophy, a strand of continent philosophy. So it is related to qualitative
Research,
So when I say qualitative learners, kay yan
based-
yung based on interview.
Yes,
Diba,
ma'am.
we
It
have
can be
the-
done through interview,
through interview.
Yes po.
When I say quantitative, kay ano man to, di ba?
numbers.
Numbers. So this is hermeneutic phenomenology is a qualitative
Research. So,
Okay.
in this particular study, ma'am, so i-interpret
Nila,
no,
yes.
i-interpret kung
Based on their
unsa
interview.
Yes,
Okay.
i-interpret kung unsay na-experience sa usa ka tawo or
Oh.
based on a person's perception.
So before they can interpret, of course, they have to interview
Yes.
the person. Okay.
Okay po. And then, let me have the proponents also. There are three proponents, no? So, we have Edmund Husserl. So, take note, si Husserl, siya ang father of phenomenology. And then, aside from Husserl, we also have Martin Heidegger. So, he is actually a disciple of Husserl. He is credited for having started the hermeneutical phenomenology. And we also have the third one, which is si Hans Georg Gadamer. So he extended the work of Heidegger's into practical application.
Okay, Ma'am Sherry. So I'm sure our learners are ready to answer the activity. So again, learners, your activity 5 for the second quarter is a picture analysis. Look for at least 5 persons to be interviewed about their perception of the given picture below. So you can see sa inyong ESLMs na mayroong picture dyan.
Yes, napod
And
siya sa
napod
screen,
sa
ma'am.
PPT, okay? So write the responses on a separate sheet of paper. Answer the following questions.
Okay.
What are those questions, Ma'am Sherry?
So again no, naiduha ka picture nga ilang interpret and then
Yes.
they need to answer these questions, ma'am. So did you get same or different responses from the people you have interviewed? No? So katong 5 ka tawo nga ilang gi-interview, no? So naabay similarities or
And
differences
differences.
when it comes to their responses. And then why do you think there is difference, no, on the perception of the interviewees though they were given exactly the same picture? So duha ra man to ka picture nga atong gibutang,
Yes,
ma'am, no?
oo.
So naa ba kung naay differences, so ngano kaha?
so makuha na to ilang perception
Yes.
sa atong pictures.
Okay, lahi-lahi
Yes.
mag-perception ang
Ang mga
kada tao,
tao.
ma'am.
Yes.
Okay, and is it normal for people to have different perception about things around us?
Okay.
No? So they need to answer those 3 questions.
Okay, based sa pictures
Nga,
nga.
gibutang nato sa ilaang activity sa SLM ug makita pod sa ilang
Yes,
screen.
okay,
karon.
learners. So you are going to interview respondents.
Yes,
okay.
5.
Only 5 persons. Okay.
Yes.
To the senior high school learners, please check the second attendance marker on the top of your screen.
Okay.
Okay.
So naa sa top.
Naa sa top. Yes.
Okay, SHS stars, now we hope that the lessons we imparted to you this afternoon will be of great help, especially in making in interpreting, no,
Yes.
interpreting human experience.
Okay, so if you have any questions or comments about the topics, please write it down below.
Yes.
Okay. So this has been your Mom City Badria Dato Dakula from Tangub City National High School.
And I'm your mom, Shermay S. Epong, still from Tangub City National High School. So keep safe, everyone. See you next week. Bye.
na sa TV, mag-aral ng maigi to get the lessons easily. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. Tayo, tayo na. Let's come and learn together, supporting one another. We love, we care, we share. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. Tangkop, tangkop time.
Hello! Welcome back mga grade 7 Mathematics. Today is another brand new day to learn another lesson in mathematics. Dito sa nag-isang programa nyo, ang Tangko! We learn all things, ang saya! Ready na ba kayo? Hooray! Now, let us begin. A mathematical phrase, a number less than 8, means that a number is being subtracted from 8. Thus, a number less than 8 can be translated into an expression as 8 minus a. Specifically, 8 minus a is an algebraic expression. Now learners, do you want to know more about algebraic expressions? Well, stay tuned and get prepared, for we will tackle another lesson. This is all about the basic terms in algebra and evaluating algebraic expressions. But first, what is algebra? Algebra is the branch of mathematics that involves expressions with variables. The following are important terms to remember in algebra. First, Algebraic expression, or simply an expression, is a mathematical phrase indicating a number, a variable, or a combination of numbers and variables and operation symbols. It is a group of terms separated by the plus or minus sign. For example, 8 minus a is an algebraic expression. Constant. A constant is a term or number with exact values. For example, in the expression 8 minus a, 8 is the constant. It is a number or a term with exact value. Variable. Variable is any letter in the alphabet representing a known value. For example, in the algebraic expression 8 minus a is the variable. Exponent. Exponent tells how many times the base is used as a factor. For example, in the expression 3 squared, 2 is the exponent and 3 is the base. The exponent 2 means we multiply 3 by itself 2 times. So we have 3 squared is equal to 3 times 3. 3 times 3 is equal to 9. Therefore, 3 squared is equal to 9. Next example. Similarly, x times x times x can be written as x cubed. The variable x is the base, and the number 3 is the exponent. The exponent tells how many times the base is used as a factor. Note, an exponent of 1 can be omitted in a term such as in 2y, xy, and negative 8x, which mean 2y to the power of 1, x to the power of 1, y to the power of 1, and negative 8x to the power of 1 respectively. Term. Term is a constant or a variable, or constants and variables multiplied together. For example, 8 minus a is an algebraic expression which contains two terms. The two terms are a and negative a. The number part of each term is called the numerical coefficient, while the variable or variables including its exponent is or are called the literal coefficients. For example, in the algebraic expression 8 minus a, now for the term negative a, the numerical coefficient is negative 1. It is the number part. Note, negative a means negative 1a. Negative 1a means negative 1 times a, which is still negative a. And the literal coefficient of the term negative a is a, the variable part including the exponent.
Now, let us have more examples. Example number 1. 4x squared plus 3y minus 2 is an algebraic expression. Terms are 4x squared, 3y, and negative 2. The constant of this expression is negative 2. The variables are x and y. The variables may represent elements of the set of real numbers. Coefficients are 4 and 3. 4 is the numerical coefficient, or the coefficient of the first term 4x squared. And 3 is the numerical coefficient or coefficient of the second term 3y. The literal coefficients are x squared and y. X squared is the literal coefficient of the first term 4x squared. Y is the literal coefficient of the second term 3y. Look at this illustration. 4x squared plus 3y minus 2. Another example. Consider the algebraic expression a cubed plus 6b. The terms are a cubed and 6b. Constant? Right, it is 0, since there is no constant term. Variables are a and b. Coefficients are 1 and 6.
In the term a cubed, 1 is the numerical coefficient, since a cubed means 1a cubed. In the term 6b, the numerical coefficient is 6. The literal coefficients of this expression are a cubed and b. A cubed is the literal coefficient of the first term a cubed. B is the literal coefficient of the second term 6b. Easy, right? Now, let us learn the classification of algebraic expressions. Algebraic expression can be classified according to the number of terms. This classification is considered a special kind of algebraic expression, which is called polynomial. Now, before classifying algebraic expression according to its number of terms, let us define first polynomial. A polynomial is an algebraic expression where each term is a constant, a variable, or a product of a constant and variable. The variable has a whole number, non-negative number exponent. Let us remember these things. An algebraic expression is not a polynomial if, first, the exponent of the variable is not a whole number. Whole numbers such as 0, 1, 2, 3, and so on. Second, the variable is inside the radical sign. And third, the variable is in the denominator. Now, let us have examples. Identify whether each algebraic expression is a polynomial or not a polynomial. First, we have 7x squared. 7x squared is a polynomial since the variable x has a whole number, non-negative number exponent, which is 2. Second, how about the algebraic expression 7 over a? Right, it is not a polynomial since the variable a is in the denominator. Third, how about this algebraic expression? Negative x squared y over 5 plus xy squared. Right, it is a polynomial since the variable x and y have a whole number, non-negative number exponents. Fourth expression, 7b to the power of negative 2 plus 2b squared. Right, it is not a polynomial since the exponent of the variable b in the first term has a negative exponent. How about this expression? Square root of x cubed. Very good, it is not a polynomial since the variable is inside the radical sign. Now learners, let us classify polynomials according to the number of terms. Monomial. It is a polynomial with only one term. Example, 2x squared contains only one term. Thus, it is called a monomial. Binomial. Binomial is a polynomial with two terms. Example, x plus 2y. Terms are x and 2y. Since it contains two terms, so x plus 2y is a binomial. Third kind is trinomial. Trinomial is a polynomial with three terms. Example, xy plus 2x minus 3y. It is a trinomial since it has three terms. The terms are xy, 2x, and negative 3y. The next kind is called multinomial. Multinomial is a polynomial with four or more terms. Example, 2mn squared minus 5m squared plus 4mn plus n. It is a multinomial since it contains four terms. The terms are 2mn squared, negative 5m squared, 4mn, and n. Do you get it? Good! Polynomials can also be classified according to its degree. Now, how to determine the degree of the polynomial? Let's start with the degree of a polynomial with one variable. In the case of a polynomial with only one variable, such as 2x cubed plus 5x squared minus 4x plus 3, where x is only the variable, the degree is the highest exponent of the variable among the terms. For example, given the polynomial 2x cubed plus 5x squared minus 4x plus 3, the degree of this polynomial is 3, since 3 is the highest exponent of the variable x among the terms. Now here are the kinds of polynomial according to its degree. First, we have constant. A constant is a polynomial of degree 0. For example, 3. 3 is a constant. Its degree is 0. Next, linear. Linear is a polynomial of degree 1. For example, x plus 3. Now, since the highest exponent of the variable x is 1, then the degree of x plus 3 is 1. You can also say that it is a first degree binomial. Thus, x plus 3 is linear. Next, we have quadratic. Quadratic is a polynomial of degree 2. For example, y squared minus 2y plus 1. Now, since the highest exponent of the variable y is 2, then the degree of this polynomial is 2. You can also say that it is a second degree trinomial. Thus, y squared minus 2y plus 1 is quadratic. Next, we have cubic. Cubic is a polynomial of degree 3. For example, 2x cubed minus 4x squared plus 3. Now, since the highest exponent of the variable x is 3, then the degree of this polynomial is 3. You can also say that it is a third degree trinomial. Thus, 2x cubed minus 4x squared plus 3 is cubic. Next, we have quartic. It is a polynomial of degree 4. For example, given a polynomial a to the power of 4 minus 3a plus 3, now since the highest exponent of the variable a is 4, then the degree of this polynomial is 4. We can also say that it is a fourth degree polynomial. Thus, a to the power of 4 minus 3a plus 3 is quartic. Next, we have quintic. It is a polynomial of degree 5. For example, given a polynomial 2m to the power of 5 minus 4m to the power of 4 minus 2m cubed plus 4, what is the degree of this polynomial? Right, the degree is 5, since the highest exponent of the variable m is 5. We can also say that it is a fifth degree polynomial. Thus, 2m to the power of 5 minus 4m to the power of 4 minus 2m cubed plus 4 is quintic.
Now, how about the degree of a polynomial with more than one variable? In the case of a polynomial with more than one variable, the degree of the polynomial is the highest sum of the exponents of the variables among the terms. Example, 2x squared y cubed plus 4xy squared minus 3xy. The degree of this polynomial is 5. Why? In the term 2x squared y cubed, the exponents of the variables x and y are 2 and 3 respectively. Their sum is 5. In the terms of 4xy squared, the exponents of the variables x and y are 1 and 2 respectively. Therefore, their sum is 3. And in the term negative 3xy, the exponents of the variables x and y are 1 and 1. Getting their sum, it is equal to 2. Since the degree of a polynomial with more than one variable is equal to the highest sum of the exponents of the variables, and since the highest sum of this expression is 5, Therefore, 5 is the degree of the expression 2x squared y cubed plus 4xy squared minus 3xy. Second example, negative PQR. What is the degree? Now, since each variable has an exponent of 1, and that is negative p to the power of 1, q to the power of 1, r to the power of 1, and the sum of their exponent is equal to 3. Therefore, the degree of this polynomial is 3. You can also say that it is a third-degree monomial. Third example, negative uv plus 10 minus u to the power of 5 v to the power of 4 plus u to the power of 4 v to the power of 5. What is the degree? If the polynomial negative uv, it has a degree 2. 10 has a degree 0. In the term negative u to the power of 5 v to the power of 4 and positive u to the power of 4 v to the power of 5 have degree 9. The highest sum of the exponents among the term is 9. Therefore, the degree of the polynomial in this expression is 9. You can also say that it is in a ninth degree polynomial. Do you get it? Great!
Remember, if the polynomial is in standard form, or the terms are arranged in descending order of exponents, the first term is called the leading term. The numerical coefficient of the leading term is called the leading coefficient. First example, 2x cubed minus 4x squared plus 3. Now, since the terms of this polynomial are arranged in descending order of exponents, thus, this polynomial is in standard form. Therefore, the leading term is 2x cubed, and the leading coefficient is 2. Second example, 2x squared y cubed plus 4x y squared minus 3xy. Now, since 5 is the degree of this polynomial, or the highest sum of the exponents of the variables from the term 2x squared y cubed, so the term 2x squared y cubed is the leading term, and 2 is the leading coefficient.
Easy, right? Now, how about evaluating algebraic expressions? When a number is substituted for the variable in a polynomial, the polynomial takes a numerical value. Finding the value is called evaluating the polynomial. Remember that replacing a variable with a number demonstrates the substitution property of equality. Let us have examples. First, let us evaluate the polynomial 6x squared plus 3 when x is equal to negative 4. Again, given x is equal to negative 4, we will now substitute negative 4 for the variable x. Then, evaluate the resulting expression. With the given polynomial, 6x squared plus 3 would be equal to 6 times negative 4 to the power of 2 plus 3. This is, again, using the substitution property. Negative 4 squared is equal to positive 16. So we now have 6 times 16 plus 3. Following the PEMDAS, we simplify first the power, then multiply, then add. 6 times 16 is equal to 96. We now have 96 plus 3. 96 plus 3 is equal to 99. Therefore, the expression 6x squared plus 3 is equal to 99 when x is equal to negative 4.
When the expression contains more than one variable, you need a value for each variable to get the numerical value of the polynomial. Look at this example. Evaluate the polynomial 2x squared minus 3y when x is equal to 2 and y is equal to negative 3. Solution. Now using the substitution property of equality, we substitute 2 to all x in the given polynomial and negative 3 to y. We now have 2x squared minus 3y is equal to 2 times the quantity of 2 to the power of 2 minus 3 times negative 3. Next, following the PEMDAS, we simplify first the power. Then, we multiply and add. 2 squared is equal to 4. Negative 3 times negative 3 is equal to positive 9. We now have 2 times 4 plus 9. 2 times 4 is equal to 8. We now have 8 plus 9. 8 plus 9 is 17. Therefore, 2x squared minus 3y is equal to 17 when x is equal to 2 and y is equal to negative 3. Complicated? No.
Now, since you already learned the basic terms of algebra and evaluating algebraic expressions, then it's time to get your activity sheet in this lesson and answer the given activities. Let us read the directions. Activity A. Fill me. Identify whether each algebraic expression is a polynomial or not a polynomial. If it is a polynomial, complete the remaining columns by filling in the correct answer or answers. Items 1 and 2 serve as your guide. Activity B. What's my value? Evaluate the following algebraic expressions using the given values. X is equal to negative 3 and y is equal to 5.
Take your time in answering the activities.
If you have questions or clarifications, you may contact the number of your teacher printed below your activity sheets.
To end, just like algebraic expressions where there are constants, in life, the only constant thing is change.
However, change has an impact in all of us. No one can escape it. That is why it is best to just embrace it. Embracing change means accepting life as it is. That's the best we can do. Grade 8 learners, stay tuned and get ready for Math 8 is coming next. Good luck and God bless everyone! Hello! Welcome back mga grade 8 Mathenics!
Today is another brand new day to learn another lesson in mathematics.
Dito sa nag-isang programa nyo,
Ang Tangkog!
we learn all things ang saya!
Ready na ba kayo?
Hooray! Now, let us begin. Last quarter, we already learned if-then statement. As a review, when we say if-then statement, it is also known as conditional statement, in which there is a hypothesis and a conclusion. The conditional is defined to be true unless a true hypothesis leads to a false conclusion.
Generally, the conditional or if-then statement is the connective most often used in reasoning. However, with some changes in words in the original statement, additional conditionals can be formed.
Now learners, stay tuned and bear with us today for we will tackle another new lesson. These are the new conditionals. These are the inverse, converse, and contrapositive of an if-then statement.
First, what do we mean by inverse statement? Inverse is a statement formed by negating the hypothesis and conclusion of the original conditional. Symbolically, the inverse is written as This symbol may be read as not P implies not Q, or if not P, then not Q. For example, in the statement, right angle is defined as an angle whose measure is 90 degrees. Now, if we are going to write it as an inverse statement, it can be done like this. If an angle is not a right angle, then it does not measure 90 degrees.
Next, let us have converse statement. Converse is a statement formed by interchanging the hypothesis and the conclusion. If in original conditional or if-then statement, P implies Q, then in converse, this can be written as Q implies P. Let us have example. If two lines do not intersect, then they are parallel. If we are to write it as a converse statement, it can be done like, if two lines are parallel, then they do not intersect. It may be noted that the converse of the definition must always be true. If this is not the case, then the definition is not valid. The converse is, therefore, can be taken as a helping tool in determining the validity of the definition. A conditional P implies Q and its converse Q implies P may or may not be true. It is important that the truth value of each converse is judged on its own merits.
Lastly is the contrapositive. Contrapositive is a statement formed by negating both the hypothesis and conclusion. If P, then Q, and also then interchanging these negations. In symbols, this may read as not Q implies not P, or if not Q, then not P. The contrapositive of a conditional statement always has the same truth value as the original statement. Therefore, the contrapositive of a definition is always true. For example, a statement, a triangle is a three-sided polygon. It is true. Now, if you are to write it as a contrapositive statement, it can be done like, a polygon with greater or less than 3 sides is not a triangle. It's also true.
Remember, a conditional P implies Q and its contrapositive, not Q then not P, must have the same truth value. When a conditional is true, its contrapositive is also true. And when a conditional is false, its contrapositive is also false. Examples. Given an if-then statement, if P then Q, we can create 3 related statements. Again, a conditional statement consists of 2 parts, a hypothesis in the if clause and a conclusion in the then clause. For instance, if it rains, then they cancel school. It rains is the hypothesis. They cancel school is the conclusion. To form the converse of the conditional statement, interchange the hypothesis and the conclusion. This can be done like, the converse of if it rains, then they cancel school would be, if they cancel school, then it rains. To form the inverse of this conditional statement, take the negation of both the hypothesis and the conclusion. The inverse of if it rains, then they cancel school would be, if it does not rain, then they do not cancel school. Lastly, to form the contrapositive of this conditional statement, interchange the hypothesis and the conclusion of the inverse statement. So, the contrapositive of this, if it rains, then they cancel school, would be, if they do not cancel school, then it does not rain.
We can summarize how to convert the statement in terms of P and Q. Look at this table. For the converse statement, we have if Q, then P. For the inverse statement, we have if not P, then not Q. For the contrapositive statement, we have if not Q, then not P.
Complicated?
No! Now, since you already learned the inverse, converse, contrapositive of an if-then statement, then it's time to get your activity sheet in this lesson and answer the given activities.
Let us read the directions. Activity A. Sort it out. In each box, you are given two statements. The first is a conditional statement, and the second could be its converse, inverse, or contrapositive. Color the boxes blue if it belongs to converse group, red if an inverse group, and yellow if it is contrapositive group. Activity B. Write each conditional statement in a converse, inverse, and contrapositive format.
Just take your time in answering the activities.
Now, if you have questions or clarifications, you may contact the number of your teachers printed below your activity sheets. To end, remember this quote: if you can't run, then walk. If you cannot walk, then crawl.
Whatever you do doesn't matter. What matters most is that you keep life moving forward.
Grade 9 learners, stay tuned and get ready for Math 9 is coming next.
Good luck and God bless everyone!
Welcome back mga grade 9 Mathenics.
Today is another brand new day to learn another lesson in mathematics.
Dito sa nag-isang programa nyo,
Ang Tangkub! We learn all things ang saya! Ready na ba kayo?
Hooray! Now, let us begin. Recall that the opposite of squaring a number is getting the square root of a number. For example, squaring 2,000 or 2,000 squared is equal to 4 million. Then taking the square root of 4 million or the square root of 4 million is equal to 2,000.
Now, recall also that a square root of a number like square root of 4 million is an example of a radical expression. Now, what is a radical expression? As a review, the symbol nth root of a to the power of m is called radical. A radical expression or a radical is an expression containing this symbol called radical sign. In the radical nth root of a to the power of m, n is called the index or order which indicates the degree of the radical, such as square root, cube root, and fourth root. A to the power of m is called the radicand, which is a number or expression inside the radical symbol, and m is the power or exponent of the radicand.
Now learners, do you know how to simplify radical expressions using the laws of radicals? Well, stay tuned and get prepared, for we will tackle another lesson today, and this is simplifying radical expressions using the laws of radicals.
Now, let us simplify radical expressions using the laws of radicals. The first law of radical is, first we have the nth root of a to the power of n is equal to a. That is, if n is odd. In this law, the index and the power of the radicand are the same. For example, cube root of 6 cube. Notice that the index and the power of the radicand are the same. So, we cancel them out And the final answer is the radicand, which is 6. Therefore, cube root of 6 cubed is equal to 6. Next law is the nth root of a to the power of n is equal to the absolute value of a. This is if a is less than 0 and n is even. For example, square root of the quantity of negative 6 squared. Notice that the value of the radicand is less than 0 and the index or the n is even. And since the index and the power of the radicand are the same, so we cancel them out. So we have the absolute value of negative 6. The absolute value of negative 6 is equal to positive 6. Therefore, square root of the quantity of negative 6 squared is equal to positive 6. Next, we have the nth root of AB is equal to the nth root of A times the nth root of B. We factor out the radicand to simplify. For example, the square root of 50. Now, to simplify square root of 50, we factor out 50. One of its factors must be a perfect square. So we have square root of 25 times square root of 2, since 25 is a perfect square. Now, let's simplify. Square root of 25 is 5. We now have 5 times square root of 2. 5 times square root of 2 is the same as 5 square root of 2. Therefore, square root of 50 is equal to 5 square root of 2.
Now let us have the third law. The third law is the nth root of a over b is equal to the nth root of a over the nth root of b. This if b is greater than 0. Let us have example. Cube root of 4 over 27. Applying the law, the cube root of 4 over 27 would be equal to the cube root of 4 over the cube root of 27. Simplifying each radicals, we now have the cube root of 4 is equal to the cube root of 4. The cube root of 27 is equal to 3. So, this is equal to the cube root of 4 over 3. The fourth law is the mth root of the nth root of a is equal to the product of m and nth root of a. And this would be also equal to the nth root of the mth root of a. Example, the sixth root of 4. The sixth root of 4 could be written as the cube root of the square root of 4, since the product of 3 and 2 is equal to 6. Now we know that the square root of 4 is equal to 2. So therefore, we can rewrite the final answer as the cube root of 2.
Do you get it? Good! Let us have more examples. Now we have removing perfect nth powers from a radicand. Any radical of order n should be simplified by removing all perfect nth powers from a radicand using the law nth root of ab is equal to the nth root of a times the nth root of b. For example, we have cube root of 54. Now, factor out 54. One of its factors must be a perfect cube. So we have 27 and 2. We now have cube root of 27 times cube root of 2. Simplify. Cube root of 27 is 3. So we now have 3 times the cube root of 2, or 3 cube root of 2. Therefore, cube root of 54 is equal to 3 cube root of 2.
Now, let us have the reduction of the index of the radical. Now, to reduce the index of the radical, we apply the law. The mth root of the nth root of a is equal to the product of m and nth root of a is equal to the nth root of the mth root of a. Let us have example. The fourth root of 64x squared. Applying the law, the fourth root of 64x squared can be written as the square root of the square root of 64x squared, since 4 could be written as the product of 2 and 2. Now the square root of 64x squared is equal to 8x. Therefore, this can be written now as the square root of 8x. The square root of 8x can be simplified into the product of the square root of 4 and the square root of 2x. Square root of 4 is equal to 2, so we now have 2 times the square root of 2x. 2 times the square root of 2x is equal to 2 square root of 2x. Notice that radical was simplified from the index of 4 to the index of 2. That is reduction of the index of the radical.
Next, we have rationalization of the denominator of the radicand. Rationalization is the process of removing the radical sign in the denominator. To rationalize the denominator, multiply numerator and denominator by a radical that will get rid of the radical in the denominator. Keep in mind that as long as you multiply the numerator and denominator by the exact same thing, the fractions will be equivalent. For example, square root of 5 over 6. Square root of 5 over 6 can be written as square root of 5 over square root of 6. Now, to rationalize the denominator, we must multiply square root of 6 by another radical that will get rid of the radical in the denominator. But here's a tip. If the denominator is a square root, then just multiply it by itself to rationalize it. In this example, the denominator is a square root. We have square root of 6. Therefore, we multiply the numerator and the denominator by square root of 6. We now have square root of 5 over square root of 6 times square root of 6 over square root of 6. Now let's simplify. Square root of 5 times square root of 6 is equal to square root of 30. Square root of 6 times square root of 6 is equal to square root of 36. We now have square root of 30 over square root of 36. Simplify. Square root of 36 can be simplified. It is equal to 6. So we now have square root of 30 over 6. Therefore, square root of 5 over 6 is equal to square root of 30 over 6. Notice that there's no radical in the final answer.
Take note, a radical expression is said to be in its simplest form if: first, no prime factor of a radicand that has an exponent equal or greater than the index, and the index of the radical is as small as possible. Second, no fraction are present in the radicand, that is, the denominator has been rationalized. And lastly, no denominator contains a radical sign. Complicated?
No. Now, since you know already how to simplify radical expressions using the laws of radicals, then it's time to get your activity sheet in this lesson and answer the given activity. Take your time in answering the activity.
Now, if you have questions or clarifications, you may contact the number of your teacher printed below your activity sheet.
To end, just like simplifying radicals, applying its laws, life has laws too. According to John F. Kennedy, change is the law of life.
And those who cannot accept that, or only look to the past, are certain to miss out the present and the future. Grade 10 learners, stay tuned and get ready for Math 10 is coming next.
Good luck and God bless everyone!
Hello! Welcome back mga grade 10 Mathematics.
Today is another brand new day to learn another lesson in mathematics.
Dito sa nag-isang programa nyo,
Ang Tangkog! We learn all things ang saya! Ready na ba kayo?
hooray! Now, let us begin. One important shape in geometry is circle. We can find it all around us. Thus, no doubt, it plays a huge part in our daily lives. Last episode, we already learned what circle is and the relationship of each parts. Now learners, bear with us today for we will tackle another new lesson. And this is all about theorems related to chords, arcs, inscribed angles, and central angles.
Now, let's start with the theorems related to central angles and their corresponding arcs. But first, let us define congruent circles. Congruent circles are circles with congruent radii. For example, line segment AB is the radius of circle A. Line segment CD is the radius of circle C. If line segment AB is congruent to line segment CD, then circle A is congruent to circle C. Now, remember that arcs in the same circle or in congruent circles which have the same measures are called congruent arcs. For example, in circle Q, arc WX is congruent to arc YZ. If circle Q is congruent to circle T, then arc WX is congruent to arc SR. And arc YZ is congruent to arc SR. Now let us have theorem 1. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. For example, in circle X, angle AXB is congruent to angle CXD. The minor arcs they intercepted are also congruent since the two central angles are congruent. Hence, arc AB is congruent to arc CD. Next example. Given circle X and circle Z. If circle X is congruent to circle Z and angle AXB is congruent to angle CXD and congruent to angle WZY, then arc AB is congruent to arc CD and congruent to arc WY.
now let us prove theorem 1. The proof consists of two parts. Part 1. Given are two congruent circles and a central angle from each circle which are congruent. The two-column proof shows that their corresponding intercepted arcs are congruent. Given circle W and circle N. Circle W is congruent to circle N. Angle AWS is congruent to angle MNR. Now prove that arc AS is congruent to arc MR. Here are the following statements with each equivalent reason. First, circle W is congruent to circle N. Angle AWS is congruent to angle MNR. Reason is, of course, given. Second, in circle W, the measure of the angle AWS is equal to the measure of arc AS. And in circle N, the measure of the angle MNR is equal to the measure of arc MR. The reason? The degree measure of the minor arc is equal to the degree measure of its central angle. Third, measure of angle AWS is equal to the measure of angle MNR. Reason? From first statement, the definition of congruent angles. Fourth, the measure of arc AS is equal to the measure of arc MR. Reason? From statement 2 and 3, this is through substitution. And lastly, Arc AS is congruent to arc MR. Reason? From statement 4, definition of congruent arcs.
Part 2. Given are two congruent circles and intercepted arcs from each circle which are congruent. The two-column proof shows that their corresponding angles are congruent. For example, given circle W and circle N. Circle W is congruent to circle N. Arc AS is congruent to arc MR. Now, let's prove angle AWS is congruent to angle MNR. Here's the proof. We have the statements and their corresponding reasons. First statement. Circle W is congruent to circle N, and arc AS is congruent to arc MR. The reason is given. Second statement. In circle W, measure of arc AS is equal to the measure of angle AWS. In circle N, measure of arc MR is equal to the measure of angle MNR. Reason? The degree measure of the minor arc is equal to the degree measure of its central angle, which intercepts the arc. Third statement. Measure of arc AS is equal to measure of arc MR. The reason is from statement number 1. This is by definition of congruent arcs. Fourth statement. Measure of angle AWS is equal to the measure of angle MNR. Reason is from statements 2 and 3. This is by substitution. Fifth statement. Measure angle AWS is congruent to measure angle MNR. Reason? From statement number 4, this is definition of congruent angles.
Do you get it? Good! Now, let us have the next theorem of circle. The theorems related to chords and their corresponding arcs, and a chord perpendicular to a diameter. Theorem 1. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Example. We have circle X and circle Y. In circle X, chord MN is congruent to chord OP. Since the chords are congruent, it follows that arc MN is congruent to arc OP. If circle X is congruent to circle Y, and chord MN is congruent to chord MP, this shows that it is also congruent to chord WZ. Then, arc MN is congruent to arc OP, and it is also congruent to arc WZ.
Theorem 2. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. For example, given circle W, line segment ST is a diameter and line segment QR is a chord. If line segment ST or the diameter is perpendicular to the line segment QR, the chord, then line segment QV is congruent to line segment VR, and arc QS is congruent to arc SR.
Now, let us prove the two theorems. For theorem 1, it is also consists of two parts. Part 1. Given circle R is congruent to circle M. Chord AE is congruent to chord OP. Now let us prove arc AE is congruent to arc OP. Here are the following statements with its equivalent reasons. First, circle R is congruent to circle M. Chord AE is congruent to chord OP. Reason is given. Second, segment RE is congruent to segment RA. It is also congruent to segment MO and congruent to segment MP. Reason? Radii of the same circle or of congruent circles are also congruent. Third, the triangle ARE is congruent to triangle OMP. Reason? SSS or side-side-side postulate. Fourth, angle ARE is congruent to angle OMP. Reason? Corresponding parts of congruent triangles are congruent. It is also known as CP-CTC. And lastly, arc AE is congruent to arc OP. Reason? From the previous theorem, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent.
Part 2. Refer to circle R and circle M. Given. Circle R is congruent to circle M. Arc AE is congruent to arc OP. Now we prove that chord AE is congruent to chord OP. Now here is the proof. The statements with their corresponding reasons. First statement. Circle R is congruent to circle M. Arc AE is congruent to arc OP. The reason is given. Second statement. Measure of arc AE is equal to the measure of arc OP. The reason is definition of congruent arcs. Third statement. Angle ARE and angle OMP are central angles. The reason is definition of central angles. Fourth statement. Measure of angle ARE is equal to the measure of arc AE. And the measure of angle OMP is equal to the measure of arc OP. The reason is the degree measure of the minor arc is the measure of the central angle which intercepts the arc. Fifth statement. Measure angle ARE is equal to the measure of angle OMP. The reason is from statements 2 and 4 by substitution. Statement 6. Line segment RE is congruent to line segment RA and congruent to line segment MO and congruent to line segment MP. Reason. The radii of the same circle or of congruent circles are congruent. Next statement. Triangle ARE is congruent to triangle OMP. The reason is SAS postulate or side-angle-side postulate. Last statement. Line segment AE is congruent to line segment OP. The reason is CP-CTC or corresponding parts of congruent triangles are congruent.
Now, how about Theorem 2? Now, learners, we will prove together Part 1 in Theorem 2. And later on, we will want you to try proving Part 2 of this Theorem 2. Ready? Alright. Part 1. Given segment ES is a diameter of circle U and perpendicular to chord GN at point I. Prove that chord ES bisects chord GN and arc GN. Now here is the proof. Each statement with its equivalent reason. First statement, circle U with diameter ES and a chord GN. Segment ES is perpendicular to segment GN. Reason is given. Second statement is angle GIU and angle NIU are right angles. Reason is the definition of perpendicular lines. Third statement, angle GIU is congruent to angle NIU. Reason, right angles are congruent. Fourth statement, segment UG is congruent to segment UN. Reason, radii of the same circle are congruent. Next statement, segment UI is congruent to segment UI. Reason, reflexive property. Next, triangle GIU and triangle NIU are right triangle. Reason, definition of right triangle. Next, triangle GIU is congruent to triangle NIU. Reason, hypotenuse leg theorem. Next statement, segment GI is congruent to segment NI. Reason, corresponding parts of congruent triangles are congruent. It is also known as CPCTC. Next statement, segment ES bisects segment GN. Reason, the definition of segment bisector. Next statement, angle GUI is congruent to angle NUI. Reason is from the seventh statement, CPCTC. Next, angle GUI and angle GUE are the same angles. Angle NUI and angle NUE are also the same angles. Reason, E, I, U are collinear. Next, the measure of angle GUI is equal to the measure of angle NUE. The reason, from the 10, 11 statement and the definition of congruent angles. Third statement, the measure of arc EG is equal to the measure of angle GUE. The measure of arc EN is equal to the measure of angle NUE. Reason, the degree measure of a minor arc is equal to the degree measure of its central angle. Next, the measure of arc EN is equal to the measure of arc EG. Reason, this is from the 12th and 13th statement through substitution. Next, the measure of angle GUS is equal to the measure of angle NUS. The reason, from the 12th statement, definition of supplementary angles, angles that are supplementary to congruent angles are congruent. Next, measure of arc GS is equal to the measure of angle GUS. Measure of arc NS is equal to the measure of angle NUS. Reason, the degree measure of a minor arc is equal to the degree measure of its central angle. Next, the measure of arc NS is equal to the measure of arc GS. Reason, from 15 and 16th statement through substitution. And lastly, segment ES bisects arc GN. Reason, definition of arc bisector.
Do you get it? Good! Now since we are already done proving the different theorems on circles, then it's time to get your activity sheet in this lesson and answer the given activity. Just take your time in answering the activity.
If you have questions or clarifications, you may contact the number of your teacher printed below your activity sheet. To end, always remember that in theorems, there is a must to show proof on a way to accept it.
But in life, it is simple. You have nothing to prove yourself, but to be yourself. Good luck and God bless everyone!
We hope that you have learned the most essential lessons you need to master. See you on our next episodes. This has been Ang Tangkub.
It's tangkub, tangkub, tangkub time. We learn all things, it's very fun, masaya. Tutok na. Tayo, tayo na. Buksan ang mga radyo, lina at matuto sa mga aral sa mundo. Tayo, tayo na. Tumutok na sa TV, mag-aral ng maigi to get the lessons easily. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. Tayo, tayo na. Let's come and learn together, supporting one another. We love, we care, we share. It's tangkub, tangkub, tangkub time. We learn all things, it's very fun, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. It's tangkub, tangkub, tangkub time. We learn all things, it's very fine, masaya. Tutok na. Tangkub, tangkub time.
Alamin ang teknolohiya sa agrikultura at pangkabuhayan upang umunlad ang ating bayan sagana sa likas na yaman. Halika na mag-ipipina, ipipina, ipipina. Halika na, mag-aral na. Alamin ang teknolohiya agrikultura at pangkabuhayan upang umunlad ang ating bayan sagana sa likas na yaman. Halika na mag-ipipina, ipipina, ipipina. Halika na, para na ipipina, 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 ipipina. Alamin ang teknolohiya sa agrikultura at pangkabuhayan upang umunlad ang ating bayan sagana sa likas na yaman. Halika na mag-ipipina, ipipina, ipipina, halika na.
we're back still here in Astral Academy
Cyber School. Okay, so let us continue sa atong discussion about the classification of polynomial according to its degree. So again, basta degree, it is the highest exponent of the variable. So applicable kung ato ang polynomial is composed of one variable only. Okay? So we are done with the constant. We have degree 0, linear, the degree is 1, quadratic, the degree is 2. How about if the degree is 3? Unsa po'y tawag ana? So we have cubic. So next classification is cubic. So cubic is a polynomial of degree 3. So example, okay, this one. 2a cubed minus 2a squared plus 1. This is a polynomial, but as you can see, ang variable na gamit is a. So looking at the variable, ang highest exponent is 3. So since the highest exponent of the variable is 3, then we can say that this polynomial is cubic. Okay, again, cubic ang tawag pag highest degree is 3. Next classification is
quartic. When we say quartic, it is a polynomial of degree 4. Okay, so manaman ta sa 0, 1, 2, 3, na napuntay 4, ang tawag is quartic. Alright.
Okay, example. If we have a to the power of 4 minus 3a plus 3, then as you can see, the highest exponent of the variable a is klaro kaayo nga 4. So since 4 is the highest exponent, so 4 is the degree of this polynomial. So since 4 is the degree, then we can say that this polynomial is quartic. Okay? Another classification or last classification is the
Quintic.
okay, we have the quintic or quintic. Right. Okay?
A polynomial of degree 5.
5. So, a polynomial of degree 5. So, klaro kaayo nga, kung polynomial of degree 5, then, ang makita na ito nga, highest exponent sa itong variable is 5. So, if we have,
So, the m na pud ta.
m na punta. Okay, here, if we have a polynomial m to the power of 5 minus 4m to the power of 4 plus m cubed minus 1, then, as you can see, learners, ang atong variable is m. The highest exponent of the variable m is very obvious, 5. Therefore, this polynomial is of degree 5. And this is called quintic. How about if ang polynomial na to, Ma'am LV, is na ay 6 or 7 or unsa ba ka nga power, no? Or highest or degree. Then, we can say, so wala specific nga tawag.
Okay.
So, pwede na ta makaingon nga, this polynomial is
It's a polynomial with degree
6 or
7.
degree 7, degree 8. So, wala specific yun nga tawag. So, na-specific nga tawag kung 0 to 5. Okay. So, this is the classification of a polynomial according to its degree. Now, how about, Ma'am LV, if nag-involve ang atong polynomial og 2 or more variables? Unsaon man pag-determine sa iya ang degree. Okay? So, to determine the degree,
We have a polynomial with more than one variable. So in the case of a polynomial with more than one variable, the degree of the polynomial is the highest sum of the exponents of the variables among the terms. So ato di ay silang i-plus, Ma'am Gay, no?
ang exponent
Yes.
sa variable.
And the highest sum would be the degree of the polynomial.
Polynomial. Okay? So, let us have an example para dili maglibog. So, if we have 3x squared y squared plus this one. Okay, here. 3x squared y squared plus 4x y squared plus 4. So, as you can see, daghan ng variables ay gamit.
right.
We have two variables here. We have x and y. So, pag daghang variables ay gamit, then, unsa man ato ang pamaagi para makadetermine ta sa degree? Highest sum of the
So, we need to
exponent
get the sum.
of the variable. So, in our first term, ang sum is, of the exponent of the variable is
2 plus 2,
2 plus 2, that is
4.
4. So, 4 ang sum. How about in this term? Pila man ang sum sa exponent sa variable?
Understood that it has 1.
Yes.
So therefore, 1 plus 2 is
3.
3.
So, constant, klaro ba nga, 0 ang degree. So, since the highest sum is 4, then we can say that this polynomial has degree, so yung degree,
4.
4. So 4 ang degree. Highest sum of the exponent of the variable.
And
So
the classification for that would be Forman, therefore it is quartic.
quartic.
That's
Okay, then we can say that this polynomial is quartic.
Quartic.
Okay, so sayon ra kaayo pag determine sa degree. So again, pag one variable, highest exponent of the variable. Pag two or more variables, highest sum of the exponent of the variables. Now let us proceed to our next concept. We have the leading term and the leading coefficient. Okay?
Dali lang.
So unsa man ang leading term, Ma'am LV, ug leading coefficient?
Okay, so if the polynomial is in standard form, that means terms are arranged in descending order of the exponent. So the first term is called the leading term.
Okay.
The numerical coefficient of the leading term is of course called the leading coefficient.
Alright. So, example, so kanilang yapon nga polynomial lang ato ang gamiton. Di ba kaganina nagkuha ta sa sum sa exponent sa variable. So in our first term, the sum is 4. The sum of the exponent is 4. In the second term, ang exponent or sum sa exponent sa variable is 3. And constant, its degree is 0 man. So we can say that nakasulat din nga polynomial in this standard form. Kaya nakasulat siya in descending order. So
That's
gikan
right.
sa term nga na pinakadako nga degree, taman sa pinakagamay nga degree. Therefore, if nakasulat siya in standard form, kaya nakasulat man nga polynomial in standard form, so the first term is called the leading term. So,
That's right.
kaniday nga term, kaya siya man ang gauna nga term, then it is called the leading term.
So
Okay?
3x squared y squared is the leading
Leading term. So, maunay leading term. So, kung naay leading term, naapoy leading coefficient. So, si leading coefficient, makita ra gyud sa leading term.
That's right.
So, when we say leading coefficient or leading numerical coefficient, so, in our leading term, unsa man itong numerical coefficient? We have 3. The number part, tapad sa mga variables or literal coefficient. So, 3 here is called our saman, leading coefficient. Okay? So, ingon anaon lang nato pag-determine si leading term o leading coefficient. Okay? So, ingon ana lang. So, another example, para dili gyud maglibog. How about polynomial that composed of one variable? This
Okay.
one.
So the concept is you must write it first into standard form.
Standard form.
So the exponents must be on descending order from highest to lowest.
Okay, here, if we have a polynomial, 2x cubed minus 4x to the power of 4 plus x. So, as you can see, atong polynomial, nag-involve of one variable only, that is x. So, pag one variable, its degree is the highest exponent. Okay? So, atong makita nga wala nakasulat in descending order
That's
or in
right.
standard form mga tuang polynomial. Kay gikan ni 3, followed by 4, followed by 1 here. So, dapat ato sa siyang standard form, okay? Para makadetermine ta sa leading term o leading coefficient. So, to write this in standard form, dapat maguna tong term nga naay highest exponent. So, maguna gini nga term. Kani si negative 4x to the power of 4. Kay siya may naay pinakadako nga exponent sa iyang variable. Followed by this term. So we have kay positive 2x cubed man na. So we have plus 2x cubed. And then followed by
The least.
the positive x or plus x. So since it is written in its standard form, then we can say that negative 4x to the power of 4 here is the leading term.
That's right.
And our leading coefficient is of course the negative 4. So ingon ana lang ka simple pag-determine. So, I guess pwede na tayo proceed sa tuang next concept
I think
about
this would be the
algebra.
last for the
Yes.
grade 7 competency this afternoon.
Yes. And we will proceed to our second competency. We're going to evaluate algebraic expression. Okay? So, what is evaluating algebraic expression?
Okay, so when a number is substituted for the variable in a polynomial, the polynomial takes a numerical value. So, to find that, this is what we call evaluating the polynomial.
Okay?
So remember that replacing a variable with a number demonstrates the substitution property of equality. So the substitution property here is the very important thing to evaluate polynomial.
Yes.
Okay.
Okay, so let us have example in evaluating algebraic expression. So if we have an algebraic expression 2x cubed minus b, 2a cubed, sorry, 2a cubed minus b, what is its value if CA is equal to 2 and b is equal to 3? So, when we say evaluating algebraic expression, meaning pangitaw na to og pila yung value given ang mga values pod sa variable. Okay? If a is equal to 2 here, b is equal to 3, pila ko na value ani nga algebraic expression. So to do that, we will use the substitution property of equality, or we have to substitute the given values of our variable. So since a here is 2, so we have 2.
Substitute or replace.
So we have 2
value
times the quantity of 2 cubed. Kay si A man is 2, so ato alang pulihan si A og 2. So we now have 2 times the quantity of 2 cubed minus
Replace b by its value, which is
okay. So we now have minus 3 since b is 3. So let us proceed to simplifying this one. So simplifying this, we must follow the PEMDAS. In this case, natay exponent, natay multiplication, naputay subtraction. So mag-start kita in simplifying the exponent, followed by multiplication, followed by subtraction. So 2 cubed is equal to 8. Since 2 cubed is 2 times 2 times 2. So we now have 2 times 8 minus 3. So multiply ta, sunod. So 2 times 8 is equal to 16. And then subtract to 3. So we now have 16 minus 3. 16 minus 3 is equal to, that is 13. Therefore, the value of the algebraic expression 2a cubed minus b, if a is equal to 2 and b is equal to 3, is equal to 13. So, ana arang evaluating algebraic expression. Mangita lang kag value given the values of its variable. So, that's it. So, I guess that concludes.
everything is clear.
Yes. If naipangutana, then you can contact us kay na may mga number no sa ilahang self-learning materials.
Okay, so more topics to be discussed after a short break. This is
Astral Academy Cyber School.
Sa Pilipino, natuto tayo magbigkas magsalita sa sariling wika, tula at kwento sa sariling bansa. Tayo na, mag-aral na tayo. A, B, C, D, E, F, G, H, I, J, K, L, M, N, N, O, P, R, S, T, U, V, W.
And we're back still here in Astral Academy Cyber School. So we are done with grade 7 mathematics. So proceed ta for our grade 8 mathematics.
Okay, so we'll start with the competency for this afternoon's topic. Okay, so for grade 8, we have determine the inverse, converse, and contrapositive of an if-then statement. Okay, so Ma'am Gay, actually, dili na nila ni bag-o. Familiar na sila aning if-then statement
Yes.
because actually last quarter pagid Ma'am Gay, we already talked about the if-then statement since we are having the thematic no nataan to. So that is why that's tong first topic sa atong grade 8 was if-then statement. Okay, so as a review lang, no, when we say if-then statement, it is also known as a conditional statement. Pasabot, we have the hypothesis and we also have the conclusion. Okay, so symbolically, when we talk about if-then statement, that would be P implies Q. Or if P, then Q.
P is the hypothesis,
and
Q,
Q would be the
conclusion.
Okay, so generally, the conditional or if-then statement is the connective most often used in reasoning. So, basically, ginagamit yun ni siya for reasoning, Ma'am Gay, no? Now, however, with some changes in words in the original statement, mo na din siya, additional conditionals can be formed. So, we already have the inverse, nga tuntunan this afternoon, converse, and the contrapositive. So, let's start with the first one, which is inverse. Okay, so when we say inverse statement, it is a statement formed by negating the hypothesis and conclusion of the original conditional. So when we say negating, Ma'am Gay, we are actually denying the truth or ang sakto na hitabo. Example, if we are saying if you are beautiful, then if we're going to negate that, if you are not beautiful. So we're taking the negative.
Yes.
Okay, so again, when we say inverse, we are negating the hypothesis and the conclusion. Okay, so symbolically, for the inverse, that means if not P,
then not Q.
Okay, so in-ana lang ka-simple. Okay, so let us have an example. Please show direct our first slide for first example so that our learners makabasa tong learners. Alright. Okay, so example, right angle is defined as an angle whose measure is 90 degrees. Okay, so basically, Ma'am Gay, kini siya nga statement is wala pa siya sa conditional nor if-then statement.
Yes.
Then, para ma-change na to siya or ma-determine na to ang iyang inverse, easier for us if we have to rewrite it first into
an if-then statement.
Okay, so go, Ma'am Gay. How are we going to translate or rewrite this into an if-then statement?
Okay, so if we have a statement, right angle is defined as an angle whose measure is 90 degrees, then writing it using an if-then statement, then we have if an angle is a right angle, then it measures 90 degrees. So nanatay if then.
That's
okay?
right.
So dali na din kaayo ma-translate nato into an inverse statement.
Okay, so balikon na to. When we say inverse, we have to negate the hypothesis and the conclusion. So basically, we already have here, if an angle is a right angle, then it measures 90 degrees. So to have our inverse statement of this conditional statement, of course, mag-negate man ta, so that means if an angle is not a right angle, then it does not measure
90 degrees.
So as simple as that, we have to negate the hypothesis and the conclusion. If not P, then
Not Q.
Okay, so that is all about inverse. Next, we already have, Ma'am Gay.
We have the converse statement. When we say converse statement, it is a statement formed by interchanging the hypothesis and the conclusion. So kung sa inverse, nag-negate ang hypothesis and conclusion, this time sa converse, atong i-interchange ang hypothesis and conclusion. Okay?
So balihon lang, no?
Balihon lang.
Okay, so symbolically, for the converse, we have, if kung sa conditional, if P implies Q, then sa converse, if Q implies P. So nabaylo si hypothesis and si conclusion. So let us have an example. Okay, so we have here, if two lines do not intersect, then they are parallel. Okay, basically, the statement is already in conditional or if-then statement. So how are we going to determine its converse? So simple ra kayo, ato rang balihon. So, again, if two lines do not intersect, then they are parallel. So, the converse statement of this would be, if two lines are parallel, then they do not intersect. Okay, so, gibali lang, gi-interchange lang si hypothesis and conclusion. And again, that is what we call converse statement. Okay, so lastly, the third one is Ma'am Gay?
We have the contrapositive statement. So when we say contrapositive, it is a statement formed by negating both the hypothesis and conclusion. So if P implies Q, and also then interchanging these negations. So, i-negate na to ang hypothesis and
That's
conclusion,
right.
then i-interchange
Bali
pag
po.
yun,
That's
no?
right.
Sa
Wala na siya
contrapositive.
combination ni
Inverse o ni converse. Alright?
Okay. So, symbolically, if so balihon man siya, no? If P
Then
implies
Q.
Q sa conditional, for the contrapositive would now be, if not Q, then not P. Okay, so let us have an example. Alright, so a triangle is a three-sided polygon. Okay, so that statement is not written in if, then, or conditional statement. So let us write it first, Ma'am Gay, into conditional
Yes.
statement. Again, a triangle is a
Three-sided
three-sided polygon.
polygon.
So Ma'am Gay, how are we going to write it?
Okay, so the conditional form is this one. If it is a triangle, then it is a three-sided polygon. So mas dali man gud nato siya i-translate into
That's right.
contrapositive kung naka if then statement ang ato ang statement
Correct.
daan.
Okay.
So translating it into contrapositive, we have
Okay, so balik ko na to, no? If it is a triangle, then
Then-
it is a three-sided polygon. Contrapositive would be, if it is not a three-sided polygon, then it is not a triangle. Okay, so that is how we rewrite the statement into contrapositive.
Positive.
So balik ko na to, the contrapositive, balikon, i-negate nimo si hypothesis and si conclusion, and at the same time, you interchange the
Okay.
hypothesis and conclusion. Alright, so that's it about inverse, converse, and contrapositive.
Contrapositive.
So next slide, please, direct for the summary.
Summary.
Alright, so please take note of this. So conditional statement, balik ko na to. If P, then
Then
Q.
Q.
For the converse, if Q, then P. Kaya ang converse is gibali raman.
interchange.
Inverse is if not P, then not Q. So ginigate na to siya. And lastly, for the contrapositive is if not Q, then not P. Interchanging and negating both hypothesis and conclusion.
Conclusion.
Alright, so Ma'am Gay, sa ilahang activity no, silahang SLM is they have to determine a inverse, the converse, and the contrapositive of an if-then statement. So,
Yes.
let us have a practice lang. Isa lang ka-example. Okay, Direct, can we have the next slide, please? Alright, so the statement is, if you attend classes regularly, then you learn a lot. Okay, so how are we going to determine its converse? So, balikon na to ang converse, balikon lang.
Yes.
See conclusion and see
Hypothesis.
So, in that case, the converse statement would be, if you learn a lot, then you attend classes regularly. So
Yes.
that is just how we determine its converse. Now, how about the inverse? Again, when we say inverse, we are negating. So if not P, then not Q. So Ma'am Gay, what would be the inverse statement of this conditional?
So again, inverse is you are going to negate the hypothesis and the conclusion. And ang given na to nga if-then statement is if you attend classes regularly, then you learn a lot. So for the inverse, it could be if you do not attend classes regularly,
That's right.
then
You
do not learn a lot. So
Okay.
ato lang i-negate si hypothesis and si conclusions.
And lastly, for the contrapositive is, if not Q, then not P. So again, to have the contrapositive of this statement, if you attend classes regularly, then you learn a lot.
lot.
So to have the contrapositive, i-negate na to an interchange. So that means, if you do not learn a lot, then you do not attend classes regularly.
Regularly.
So, as simple as that. Okay, so we hope that the three conditionals, the inverse, converse, and the contrapositive are very clear sa inyo ha class. Okay, so more topics to be discussed after a short break. This is
Astral Academy Cyber School.
This is the way we speak. This is the way we read. This is the way we write. This is the English way. This is the way we speak. This is the way we read. This is the way we write. This is the English way. Come and learn to speak and write of the language of the world. Learn to understand the love.
And we're back, still here in Astral Academy
Cyber School.
Alright, so humanat na sa ato ang grade 8 lesson kaganina. So magpadayon ta, Ma'am Gabe. This time, we will now have the grade 9 lesson.
Okay, so for grade 9 mathematics, mo na itong competency for week 5 of quarter 2. We have to simplify radical expressions using the laws of radicals. So before na mag-simplify the radical expressions using the laws of radicals, of course, let us have a review first kung sa dining gitawag nga radical or radical expression. So when we say radical or radical expression, it is an expression containing the symbol. So kani nga symbol. Okay? So if makita mo ingon ani nga symbol, then that expression is a radical or a radical expression. Okay? So if we have an expression nth root of a raised to the power of m, okay, here we have nth root of a raised to the power of m. This is a radical expression. So kaning n nato dire nagrepresent og number. Specifically, ang number nga naa diri nga part, nga nakasulat diri nga part, gamay nga number nga naa diri nga part is called the index. So review na lang man eh. So I guess na mo idea og unsa na. We have index, and si a here nagrepresent og radicand. So number po din siya nga na inside sa radical, and m here is the exponent of the radicand rather. So balik ta si index, that index indicates the order or the degree of the radical. So if we have this one, example, if we have square root of 8, then square root man ito ang radical sign, the radical symbol, then the degree of the square root is, it is understood naman no, basta square root, its degree is 2. But no need to write na 2 because understandable na siya pag square root, 2 automatically ang degree and index, okay, or degree sa ato ang radical. So in this radical expression, the index is 2, the radicand here is 8, and the exponent of the radicand is 1. Okay? Another example, if we have a radical expression, this one, cube root of 2 cube. Okay? So ang degree sa atong radical is 3 na since the index is 3. So 3 here is called the index, 2 here is called the radicand, and 3 here is the exponent of our radicand. So, ingon ana lang ang definition ni radical or radical expression. Okay? So, now how about simplifying? Okay, how about simplifying a radical expression? So, how to simplify a radical expression? Of course, we will use the laws of radicals. Okay? So, what is our first law?
Okay, so the first law of radicals is we have
In this law, the index and the power of the radicand are the same. So cancel them out. So the answer is what we call radicand.
Okay. So the first law of radical is this one. If we have here,
Same.
okay, if we have nth root of a raised to the power of n, that is equal to a. So, same ang index ug same ang power sa ato ang radicand. Automatically, cancel the radical symbol and the power of the radicand. So, ang nabili na lang is the radicand itself. This is applicable ni siya Ma'am LV, if ang n nato or index is odd. Okay? Applicable po ni siya if ang n nato or index is even, but our radicand is greater than 0. Okay? So, let us have an example. Here. If we have cube root of 2 cubed. So, as you can see, the index, which is n, is odd. So, we can apply this first law. So, pariha ang index na to o pariha po ng exponent sa atong radicand. All we have to do is cancel them out and then ang nahibili na lang is the radicand. Okay, so, therefore, we can say that cube root of 2 cubed is equal to 2. So, applicable ang first law na to kung pariha ang index o ang exponent sa radicand. That is if n is odd. How about if n is even and a is greater than 0? So, magamit gyapon nato ang ato ang first law. So, here we have square root of 6 squared. So, simplifying square root of 6 squared, we can apply this law. So, same ang index na to, which is 2. Same sa exponent sa atong radicand. So, cancel them out. So, ang naibili na lang is the radicand, which is 6. Therefore, square root of 6 squared is equal to 6. Now, how about if the index na to is even, but the radicand is less than 0?
Or negative.
Okay, or negative. A or radicand less than 0, that would be mga negative numbers. So, example, how to simplify square root of this one? Okay, square root of negative 6 squared. So, timanan, the index is even, but the radicand is negative. The radicand is less than 0. So, dili ta automatically maka-apply ani, no? So, our answer would be, we have to get the absolute value of the radicand. So, maka-cancel gihapon ta sa ato ang radical symbol o sa ato ang power sa radicand. But, our answer must be, we have to get the absolute value of our radicand. So, therefore, when we say absolute value, it is always positive. So, absolute value of negative 6, that is equal to positive 6. So, therefore, square root of negative 6 squared is equal to positive 6. So, basin hag, makaka-encounter mo gani nga problem class, and then your answer is negative 6, then wrong na dayon mo. So, timanan, if n is even or index is even and the radicand is less than 0, then you have to get the absolute value of the radicand. So, ang answer would be the absolute value of the radicand. So, that is all about our first law of radical. Okay? How about the second law?
Okay, so the first law no would tell us that easier lang siya if the index and the power are the same.
Yes.
So all you have to do is cancel them
Cancel.
out and it's just equal to its radicand. Inana lang gid kadali.
Wala na yung mga langay-langay nga
simplify
computation. Okay.
But you have to take note, pag negative si radicand, of course, dili siya equal to its negative. But you have to get the absolute value, so positive gihapon
Yes.
ang iyang answer. Okay, so the second one is
We have the nth root of AB is equal to the nth root of A times the nth root of B. So, yun, ani lang. Given si nth root of AB or nth root of A times B, ang answer is, i-factor out lang nato ang given. So, we have the nth root of A times the nth root of B. Let us have an example. If we have square root of 50, so how to simplify square root of 50? So, as you can see, square root of 50,
pwede ta makasimplify niya by factoring the radicand, di ba?
Because it's
So,
not perfect square.
yes. So, mangita tag in factoring or not, mangita tag factor rather. So, mangita tag factor ni radicand na to ng 50, nga ang isa ka factor is a perfect square para ma-simplify pa nato siya. Since ang ato ang index is 2 or since ang atong radical sa is square root man, dapat ang isa ka factor ni 50 is a perfect square. So, what are the factors of 50? So, pwede mo mag-trial and error, no? To get the factors of 50. So, if we have
To choose
the
itong factor is a one factor is a
perfect square. So, if ever maka-encounter mo ganyan nga problem, then ang radicand is wala gyoy factor nga ang isa perfect square, then that is simplified form na nga
Yes.
radical expression. But in this case, pwede pa. No? Kaya na-factor si 50 nga ang isa perfect square. And that is 25 and 2.
Right.
So, we have square root of 50 can be written as square root of 25 times square root of 2. So, yun anak lang. Square root of 25 can be simplified. When we say square root of 25, unsa man nga number nga i-times sa yung kaugalingon, 25 ang answer. So, that is equal to 5. The square root of 25 is equal to 5. So, times square root of 2. 2 is not a perfect square. So, wala gyud tay makita nga whole number nga answer ni square root of 2. So, copy lang nimo siya. So, we now have 5 times square root of 2. 5 times square root of 2 can be written as 5 square root of 2. Therefore, this is our final answer. So, simplifying square root of 50, we obtained 5 square root of 2. So, this is all about our second law. So, ato lang i-factor out ang ato ang radicand and then make sure ang isa ka factor ma-simplify.
That's right.
Okay? So, kung square root ang given, perfect square dapat ang isa ka factor.
Kung
Kung
cube
cube
root,
root, perfect
perfect
cube.
cube.
Pod ang inyong kinahanglan nga pangitaon. Okay? So, this is all about our second law. Okay? How about our third law? So, we have
Okay, so for the third law, if we have the nth root of a over b, that would be equal to the nth root of a over the nth root of b.
okay. So, given nth root of a over b, so atong radicand is fraction na. So, pwede na to na siya isulat as separate. So, i-separate na to ang nth root ni numerator og ni nth root sa denominator. So, yun, anaon lang. And then, simplify afterwards. Example, if we have this one, cube root of 4 over 27. So, how to simplify cube root of 4 over 27? So, simplifying this, pwede nato siya isulat as this one. I-separate lang nato si numerator o si denominator. So, we have cube root of 4 over cube root of 27. Okay? So, in our numerator, we have cube root of 4. So, nauna-una ninyo, simplify pa ba si cube root of 4? 4 is not a perfect cube. So,
That's
meaning, di na gyud siya ma-simplify. Huwag gyud siya whole number nga answer. But how about cube root of 27? Naabay number, i-times sa kaugalingon katulo, 27 ang answer.
Yes.
So, naa-gyud, no? And that is what?
3.
3, because 3 times 3 is 27. Therefore, we can simplify this as, kopyahon lang nato si numerator nato. We have cube root of 4 over cube root of 27 is equal to 3. So, this is our final answer. This is the simplified form of cube root of 4 over 27. So, mangita gyud mo way unsaon pag-simplify ang given radical expression. So, yun ana lang. Now, how about if ingon ani ato ang radical expression? How about this one, Ma'am LV? We have here square root of 1/2. Okay? Square root of 1/2, simplifying this, we can apply our third law. Nga pwede na to i-separate si numerator o denominator. So, we have square root of 1 over square root of 2. Okay? Square root of 1 can be simplified because 1 is a perfect square.
That's right.
But square root of 2, dili na no, simplified form na siya. So, we have, dili lang nato ang sumpay, square root of 1 is equal to 1. And then, you copy square root of 2. Take note, learners, nga si radical expression or radical is considered to be simplified kung wala na tayo makita nga radical sa denominator. So, bahalag na yung radical sa numerator class, it's okay. As long as sa denominator, sa numerator rather, so as long as sa denominator, wala tayo makita ng radical sign. So, in this case, ato apagid siyang is-simplify.
Correct.
So, simplifying this, we are going to rationalize. Okay? Ang term na nga gamiton is rationalize. Okay? So when we say rationalize or rationalizing or rationalization, that is the process of removing the radical sign in the denominator. So here, sa square root of 2, ato ang i-rationalize para mawala na ginang radical sa denominator. So, removing the radical in the denominator, natay i-multiply dapat ni square root of 2 nga mahimong ang result is a perfect square para
Wala na yung radical sign.
Yes, para ma-simplify na to. So, to simplify this, unsa may i-times sa ito ng square root of 2 nga para ang result may mong perfect square. So, that would be square root of 2 gihapon ang ato ang i-multiply, no? Kay square root of 2 times square root of 2 is square root of 4. And 4 is a perfect square na, so pwede na nato ma-simplify da. Yun.
Yes.
So, if nag-multiply ka sa denominator of square root of 2, dili kalimtan si numerator. Same gihapon ang imuhang buhaton.
It's like you're multiplying 1.
Yes, okay? So, multiplying 1, wag yung mausab sa ato ang pag-multiply. So, here, let us proceed. 1 times square root of 2, that is square root of 2. Any number or expression multiplied by 1 is the expression, okay? Over square root of 2, square root of 2 times square root of 2, that is square root of 4. And square root of 4, pwede na ito ma-simplify because 4 is a perfect square. So, we have our final answer, square root of 2 over
Square root of 4 is 2.
square root of 4 is 2, so we have square root of 2 over 2. So, this is our answer. Therefore, square root of 1/2 is equal to square root of 2 over 2. So, ayun ana lang ato ang third law. Alright? Now, how about our last law? So, we have
Okay, for our last law, we have here the mth root of the nth root of a is just equal to the m times nth root of a, and that would be equal to nth root of the mth root of a.
okay.
So, ning mga mth root
Daghan
nato
kay
ma'am Gay,
nth
pakita
root.
nila ni karon.
Alright, so for our last law or the fourth law of radical, we have here. Mth root of the nth root of a can be written as m times nth root of a. Pwede pod, we have nth root of the mth root of a. Okay? So, murag complicated kay lang taon class, no? Kaya dagang nth root, mth root. But, para masabtan, let us have an example.
That's right.
Okay. If we have square root o sixth root of 4. Okay. Now, how to simplify sixth root of 4? So, simplifying sixth root of 4, we can use this law. Okay? So, sixth root of 4, since the degree man is 6, kaya index is 6, then, pwede ito siya masulat as square root of the cube root, Ma'am Elvie, no?
Yes, kasi
Pwede
times
pod
three is
2 times 3. I-times ito ang index that is 6. The sixth root. Okay? Pwede pod bali, like cube root of the square root.
Yes.
So, magdepende learners sa ato ang radicand o kung sa atong i-simplify. Since 4 is a perfect square, so magamit tani. Okay? We are going to use cube root of the square root kay 4 is a perfect square man.
right.
So, we have cube root of the square root of 4 na dayon. Okay? Square root of 4
Is equal
is
to 2.
equal to 2. So, we now have, ang nabili na lang is the cube root of 2. Again, cube root of 4 is equal to 2. Then, naapay radical symbol nga nahibilin, which is the cube root. Okay? So, since cube root of 2 is in its simplified form na, kay 2 is not a perfect cube man, then this is our final answer. So, 6 root of 4 is equal to the cube root of 2.
That's right.
So, this is all about our fourth law. I hope inyong nasabtan ang ato ang laws of radicals. So, kung saan pag-simplify ang radical expression using these laws. Okay? So, that concludes our grade 9 mathematics lesson. So, grade 10 math will be discussed after this short break. This is Astral Academy Cyber School.
matuto sa mga aral sa mundo. Tayo na. Tumutok na sa TV, mag-aral ng maigi to get the lessons easily. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. Tayo na. Let's come and learn together, supporting one another. We love, we care, we share. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop, tangkop, tangkop time. We learn all things, it's very fine, masaya.
So we're back, still here in Astral Academy Cyber School. So we are done with our grade 9 mathematics learners. So now let us proceed to our grade 10 math lesson.
Alright, so Ma'am Gay, here is our competency for Math 10. So, proves theorems related to chords, arcs, central angles, and inscribed angles. Actually, Ma'am Gay, ang mga provings ani nakita na nila sa atong video lesson
Yes.
kanina. Well, anyway, so we'll just have short or few theorems lang atong i-prove this afternoon. Alright, so last episode we already learned what circle is and the relationship of its parts. So, before tayo mag-start sa pag-proving na ito, Ma'am Gay, we have to start first by defining what congruent circles kay mo man ito siya magamit later on sa atong proving.
Yes.
Okay. So, para makabalo sila, when we say congruent circles, these are circles with congruent radii. Okay? So, Direct, can we show the first slide, please, for the grade 10? Alright. So, we have here congruent circles. So as you can see, we have there circle A and circle C. Okay, so chord AD is the radius, or segment AB is the radius of circle A. And as you can see that side CD is, or segment CD is also the radius of circle C. Now in that case, we can say that AB and CD are congruent. And if they are congruent, then circle A, we can also say that circle A is also congruent to circle C. And that is what we call congruent circles. Alright, so Ma'am Gay, let's proceed for the first theorem. So first we have the theorem related to central angles and their corresponding arcs. So, as you can see, we have there the theorem. Theorem 1, Direct, please show. Alright. Theorem 1, please. Alright. So, in a circle, or
in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So, atong theorem 1, ang two minor arcs are congruent if and only if ang central angles nga nag-intercept nila are also congruent.
Okay, so let's review first on what minor arcs, Ma'am Gayna.
Yes.
So when we talk about minor arcs, these are actually arcs that is, or measures less than 180 degrees. All right. Now, when we talk about central angles, these are angles, Ma'am Gay, where the vertex of the angle is on the center of the circle. And of course, the sides of the angles are the radii. Okay, so sa theorem number 1 is congruent circle siya if two minor arcs are congruent. So in this case, if kini siya nga arcs are congruent, then we can also say its corresponding central angles are also congruent. So in that case, kini ato ang angle W would be equal to angle N pod. All right. Now, let us have the proving. All right. So first, we have there our given. Okay, so as you can see, there the figure, given circle W is congruent to circle N. Another given is angle AWS is congruent to angle M and R. Now let us prove that arc AS, the minor arc AS, is congruent to the minor arc MR. Alright, so here is now the proof. Okay, so of course, Ma'am Gay, usually pag sa ato ang proving, no, we have proving in grade 9 and grade 10, we are actually using the two-column proofs.
Yes.
So that means we have the statement for the first column and the reason for the second column. Okay, so let us now have the proof. First is, of course, we have to start with the given. First statement would be, circle W is congruent to circle N. And angle AWS is congruent to angle MNR. Reason, of course, it is
Given.
Alright, so second statement would be, it follows that
In circle W, we have the measure of angle AWS is equal to the measure of arc AS. Okay? So, the measure of the central angle AWS, so here, is equal to the measure of this, its intercepted arc AS.
Okay, the reason is the degree measure of the minor arc is equal to the degree measure of its central angle. Actually, we already have this theorem during our last episodes. Okay, so the degree of the measure of the minor arc is just equal to the degree of its central angle. So example, if the central angle W is equal to 30 degrees, then we could say that arc AS is also 30 degrees. So that would be our second statement. And it follows that in circle N, the measure of the angle MNR is equal to the measure of arc MR. Because again, the reason is the measure of the minor arc is equal to the measure of its central angle. Okay, now third statement would be from the given first statement, angle AWS is congruent to angle MNR. So it follows that the measure of angle AWS is also equal to the measure of angle MNR. The reason for that is, of course, definition of congruent angles. Kay congruent man ilang angles, din pasabot, same pud sila og measurement, Ma'am Gay.
Equal.
Okay, so next is through substitution. Since we already know that the measure of angle AWS is equal to the measure of angle MNR, and we know that measure of angle AWS is equal to the measure of arc AS, then that means the fourth statement would be measure of arc AS is equal to the measure of arc MR. Okay? So the measure of arc AS is equal to the measure of arc MR. Reason, of course, substitution. And lastly, since we already know that the measure of arc AS is equal to the measure of arc MR, then it follows that the arc AS is congruent to arc MR. And that reason, definition of congruent arcs. And that proves that in a circle, if I'm sorry, what was that again?
If
the
congruent ang
minor arcs in
yes.
circles, if the minor arcs are congruent, then their central angles are also congruent. All right. Okay, so that proves the first theorem. All right, so now let us proceed to the second one. Actually, Ma'am Gay, dakan pa tong theorems ato ang related to arcs and central angles.
Yes,
but
yes.
we'll, as you can see, na-discuss na nato tong video lesson kaganina. All right, so now let's proceed to theorems related to chords and their corresponding arcs and the chord perpendicular to a diameter. So let's have one theorem in this case. Okay, so this theorem, please show direct. So in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so makita nato na siya diri sa atong figure. Okay, so ang two congruent circles, two minor arcs here, example, arc AE and arc OP are congruent, then it follows that their corresponding chord are also congruent. So pasabot, ang chord AE is congruent to chord OP.
Pwede po bali, no?
Yes.
Like,
okay.
equal or same measure ang chord, then its corresponding minor arc are also congruent.
Okay, so here is the proof. Okay, so as you can see, it's on the slide. Okay, so given circle R is congruent to circle M. Okay, so makita natin ang figure. Another given, chord AE, this side, is congruent to chord OP. That is given, ha? Now, let us prove that arc AE is congruent to arc OP. Okay. So, let's start the proving. Of course, Ma'am Gay, we have to start with a statement.
Yes. So our first statement would be, kasagara gid sa first statement nato Ma'am LV is the given. So kung
okay,
sa
diha man gud ta magbase.
yes,
na, no?
diha man ta mag-base. So so kung mag quiz ani, of course na nagid moy sakto nga answer,
1
no?
point.
1 point, 2
Or 2
points.
points, I'm
yes.
sorry.
So we have our first statement, we have circle R is congruent to circle M. Also we have a chord AE is congruent to chord OP. The reason is of course given. Okay. And for our second statement, that would be...
Okay, so if you're going to get the raday, no? Kay raday magini siya, Ma'am Gay, no?
Yes.
Okay, so don't mind na hiwi. Okay? So as you can see, segment, it follows that segment RE, kini nga raday, is congruent to segment RA. Because ang definition, raday of same circles or of congruent circles are congruent. So when we talk about the radius, magid Ma'am Dino, same measurement magid na from the center to the point of any of the point of the circle. So that is raday. So that is congruent, and it follows that side MO, kay congruent circles man siya, this is also congruent to side or raday MP. Again, the reason is raday of same circles are congruent. The next statement would be, as you can see, na natay makita nga triangle, Ma'am Gay, na?
Yes.
Alright, so third statement would be then followed that triangle ARE is congruent to triangle OMP. The reason is SSS postulate. So, ganyan yung SSS postulate, Ma'am Gay?
We have the side postulate.
Okay, side postulate. So, kini siya ato ang mga sides. Then, if that's the third statement, then it would be follow that angle ARE, kini siya nga angle, Ma'am Gay, ARE, the central angle, okay, is congruent to angle OMP.
Yes.
Okay, central angle of the second triangle. Reason, corresponding parts of congruent triangles are congruent. Mo ni siya common gitawag na to CPCTC. So, corresponding parts of congruent triangles are congruent. So, pasabot, ang kining ilahang central angles are congruent. Those sides, corresponding sides, are also congruent. Okay, then since ang atong central angles are congruent, then it follows sa ato ang last statements atong proving na arc AE, this side, is congruent to arc OP. What is the reason? From the previous theorem, katong atong gi-prove kaganina, Ma'am Gay, no? In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Now, since for our fourth statement, it shows that angle R and angle O, which are the central angles, are congruent, then therefore it follows that their corresponding arcs are also congruent. So therefore, arc AE is congruent to arc OP. Okay, so that's it. Now, next is theorem on inscribed angle and its intercepted arc. Okay, so we have there. Can you read the theorem, Ma'am Gay?
Yes, so for theorem 1 on inscribed angle and its intercepted arc, we have if an angle is inscribed in a circle, then measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. Okay?
So if an angle is inscribed angle, again, a review when we talk about
Inscribed.
angle, it is an angle where the vertex is on the circle.
Circle.
Just like this, Ma'am Gay. I'm sorry. This angle A is considered as an inscribed angle since the vertex is on
The circle.
and the sides are chords of the circle. Alright, so let us now prove that it is equal to 1/2 of the intercepted arc. Okay, so example, if this is 60 degrees, then it shows that arc BC is equal to 30 degrees since it is equal to 1/2 of the intercepted arc. Okay, so now let us have the proving. Next slide, direct. All right. So as you can see, we have there given circle O with inscribed angle, angle BAC, and AC is a diameter. Now let us prove again that measure of angle BAC, or the inscribed angle, is just equal to 1/2 of its intercepted arc, or measure of arc BC. Okay, so first statement, of course, wala na ilain. First
The
statement and
given.
reason, given. Given circle O with the inscribed angle, angle BAC, and diameter AC, reason is given. Okay, next. What about if you have to draw
Segment OB.
segment OB? Okay, that would be our second statement. So that maka-form ta diri og triangle. Reason, 2 points determine exactly one line. Okay, so kining point O and kining point B, pag i-connect, we can have one line. Okay, next, it follows that segment OA, alright, kini siya nga side. Segment OA is congruent to segment OB. Very obvious ang reason. Ang reason is, of course, radii of a circles are congruent. Again, since the line is from the center of the circle to any point of the circle, that is radius. Alright, next. Since we already have here triangle, then we have triangle BAO is an isosceles triangle. Nganong matawag man nato siya isosceles triangle? Si triangle BAO. Since both sides, si side BO and AO or OA are both radius of the circle, then therefore they have the same measurement. And of course, when we talk about isosceles triangle, it is a triangle where two sides of the triangle are congruent. So
Okay.
in that case, the reason would be definition of isosceles triangle. All right, the next, we have angle BAC is congruent to angle OBA. Again, angle BAC is congruent to angle OBA. Reason, of course, isosceles triangle theorem. Okay, so natin nalimtan, Ma'am Gayno, between 5 and 6. Since we have in a statement angle BAC is congruent to angle OBA, it follows that the measure of angle BAC is congruent to the measure of angle OBA. Kaya magamit natin itong substitution later on. Okay, so the next statement is, the reason would be here is, of course, congruent, definition of congruent angles. Right, Ma'am Gay? Okay, so next, it follows that the measure of angle BOC is equal to the measure of angle BAC plus measure of angle OBA. Reason, Ma'am Gay, is measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. As you can see, in this triangle, we have here the exterior angle. So again, when we talk about exterior angle, gawas, kung i-extend na to ang line, or isa ka side sa triangle, ang ma-form ang angle is called an exterior angle. And the remote interior angles are the two angles. Kini would be the two remote interior angles. Opposite sa exterior angles. Okay, so again, we have there the statement, measure of angle BOC is equal to the measure of angle BAC plus measure of angle OBA. Now, this case, it follows that if we're going to substitute, Ma'am Gay, since we already know that the measure of angle OBA is just the same as the measure, kini siya nga statement, Ma'am Gay, angle BAC, that if we're going to substitute would now be, second statement, Ma'am Gay, measure of angle BOC is equal to the measure of angle BAC plus measure of angle BAC.
Yes.
Same ra sila. So reason, substitution property. We just replace the measure of angle OBA by the measure of angle BAC. Alright. Next, of course, same man sila of lateral coefficient. So we can say that the measure of angle BOC is equal to 2 times measure of angle BAC. Okay, the next statement would be measure of angle BOC is just equal to the measure of arc BC. Reason, of course, mo nitong theorem kaganina, the measure of a central angle is equal to the measure of its intercepted arc. Alright, then, by using the transitive property, again, pag transitive property, if A is equal to B and B is equal to C, then A is equal to C. So, pasabot that 2M, 2 times the measure of angle BAC is equal to the measure of arc
BC.
Again, the reason is transitive
Property.
property of equality.
Okay.
And lastly, since we already have there 2, using the multiplication property of equality, we can divide both sides of the equation by 2. So, pasabot that the measure of angle BAC is just equal to 1/2 of the measure of arc BC. And that shows the proving of our last theorem. Alright, so it's quite a long process. It's quite a long day, Ma'am Gay. So, again, mag-goodbye na ta, Ma'am Gay. Magpasalamat na kita. Alright. Okay, before that, let us not forget our last attendance marker for this afternoon. Alright, so please take note, learners. Alright, Ma'am Gay, magpasalamat na kita. Of course, ang pinakauna, ang atong executive producer, our SDS, Sir Gus Sepe. And of course, Ma'am Gay,
And of course, we're going to thank our production team. We have here Sir Saavedra, Sir Bagaboy Boy, Sir Sultan,
Sir RR, and Sir Norbel Holyo
Yes.
III. Alright, so, kita kids, see you in our next live. Again, this has been Elvin Nueva.
and Ma'am Gay Soterio Saavedra,
This is
Astral Academy Cyber School.
Bye!